Hi, and now I'm going to demonstrate the data collection for lab 7. Try to use this equation to find the moment of inertia. So this equation is super important. Try to explain each component in the equation and how we're going to collect those data today. So the first part, which is t over 2 pi squared. I hope you guys can see that, but if you cannot, I'm not sure, but if you cannot, just look it up on your lab manual. So the first part of the equation is t over 2 pi squared. So how do we find t? T means we want to hand this object, and that is swing with really small degree, within 5 degrees. And the time it takes for a complete swing is t. So I start from here, swing to here, and come back. This is a complete swing, and the time takes for a complete swing is t in this equation. And how about m? M is mass of the object. So we got a scale here. Not scale. We got a scale. We're going to hand it up here and find the weight of the object. And the next is G. G is gravity, which is equal to 9.8. And also L. L is a length from center of mass to the axis of rotation. So for today, we have two objects. One is a baseball bat. The other is a rocket. We're going to find moment of inertia when it's hand at a grip, and also hand on the other side. Also the racket, hand on the grip, and also hand on the other side. So we need to figure out the distance from center of mass to the axis of rotation. How do we find center of mass? We use a very old school method. Use our finger, try to balance it. So when I balance it like this, my finger is at the center of mass. Then I'm going to measure the length from axis of rotation to center of mass. So if I'm handing the racket on the grip, the length would be from the grip to the center of mass. But if I'm handing on the other end, the length will be from the other end to the center of mass. So make sure you remember this. Oh, well, I'm going to complete the data sheet for you, so don't worry. But just a heads up that the length will be different when you hand on different side. And also for the baseball bat, like this. Try to find the center of mass. And I'll figure it out later. But when you find the center of mass and figure out the length from the other end to the center of mass, or from grip to the center of mass, depends on which side you're handing on when you're handing this object. So we got T, which is the time for a complete swing. We got M, which is mass. We have the scale to measure it. And we got G, which is 9.8. The L is from center of mass to the axis of rotation, which is the side when you're handing this object. And how do we swing it? We got a pretty good lab setup here. So take this baseball bat for example. I'm going to put it here. So you can hand it on at the grip. Then I'm going to swing it like this. Okay. So 1 complete swing, 2 complete swing, 3 complete swing. But because the time for 1 complete swing is pretty short, so basically we're going to have 10 complete swings, and we measure the total time and divide by 10, which is the average time for 1 complete swing. That's why I got the timer here. Okay, so I just demonstrated one data collection for you, and I'll finish the data sheet and you're good to calculate it. I don't want to complete the whole data collection and make the video super long, and you're going to fall asleep. Alright. So let's hand the baseball bat at the grip. And I'll start from 5 degree. And I have a timer. Start. 1 swing, 2 swing, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Here's the time it takes for 10 complete swings, which is 16.26. I'm gonna write it down. Okay, and then I'm going to switch it to the other end. Alright, and also I'm going to time how long does it take for 10 complete swings. So, start from 5 degree, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, got the time, which is a little bit shorter, 14.79. Okay, then you got the time, divide by 10, you can calculate the average time for one complete swing. Then, according to the equation, we need a mass of this baseball bat. So, got a scale here. How heavy is it? It's about 2, 4, 6, 8. I would say 7.5 newtons. So it's 7.5 newtons. But we need to convert it to kilogram. I'll do it for you later. So for now it's 7.5 newtons. Then we need to measure the length from grip to the center of mass, and also from head to the center of mass. So from the center of mass, takes a while. Okay, very good. Center of mass is here. And I'm going to measure from grip to center of mass. So 54 centimeters. Which is 0.54 centimeters from the grip. And then, I'll use the total length and minus the grip from grip to center of mass, which will be from head to center of mass. So that'll be the total length is, it's hard to do it by myself, but okay, it's 86.86 minus 50.54, which is 0.32, I believe. Yeah, so now we got all the data for a baseball bat. And I'm going to collect the data for this rocket for you, but I don't plan to show it in the video. And that's the data question for today's lab, and you need to calculate the moment of inertia in exercise 1 and find the moment of inertia when the axis of rotation is at the center of mass in exercise 2. Okay, I'll see you later.